The crystalline chamber at the Galactic Academy sparkled with the late afternoon light of 3 suns, casting rainbow patterns across the gathered students. Professor Xylan's translucent appendages clicked against the data crystal podium as she surveyed the graduating class of xenobiologists. "Your final assignments," she announced, her crystalline form refracting light in patterns that conveyed both enthusiasm and solemnity. The chamber hummed with nervous energy as students of various species shifted in their gravity-adjusted seats. Among them, Crix adjusted his light-processing facets, trying to capture every nuance of the professor's chromatic speech. His crystalline structure, similar to the professor's but with a distinctive blue tint, sparkled with anticipation. Beside him, Zeph's mercury-like form rippled with excitement, their silver surface catching and reflecting the ambient light. In the low-gravity section of the chamber, Nari hovered delicately in her support harness, her gossamer thin limbs swaying gently. Each team, Professor Xylan continued, her colors shifting to academic orange, will receive a sealed data crystal containing their research subject. Your task is to document and analyze your assigned phenomenon without relying on existing academic databases. Crix's crystalline heart chimed with excitement as a sealed crystal landed on their team's desk with a soft ping. Zeph flowed closer, their liquid metal form condensing with curiosity, while Nari carefully adjusted her harness to lean forward. "Team 7, Zeph read aloud, their voice rippling like gentle waves. "We're assigned to study Earth." Nari's gossamer limbs trembled. "The Class 12 Deathworld. There must be a mistake." Professor Xylan's colors shifted to attention-demanding red. "There are no mistakes in these assignments. Each team has been carefully matched to their subject based on their unique perspectives and abilities." Crix refracted thoughtfully, processing the implications through his mineral matrices. Earth's classification has always been controversial. A Class 12 Deathworld shouldn't be capable of producing a spacefaring civilization, yet humans are already establishing colonies in their solar system. "Precisely," Professor Xylan chimed, her crystalline form brightening with approval. "Your team's diversity makes you uniquely qualified to study Earth from multiple perspectives." Crix's crystalline analysis, Zeph's fluid adaptability, and Nari's experience with gravitational challenges will provide valuable insights. Zeph rippled with determination, their mercury surface forming complex patterns. "But Professor, won't studying the Deathworld be dangerous, even through remote observation?" "All necessary safety protocols are included in your data crystal," Professor Xylan assured them, her colors shifting to calming blue. "Your task is to analyze and document, not to visit. Though I should warn you, what you discover may challenge everything you think you know about planetary classification." Nari's thin fingers danced across the sealed crystal surface. "The humans themselves claim their world isn't particularly dangerous. Could an entire species be so unaware of their deadly environment?" "That," Professor Xylan chimed, her colors displaying academic amusement, "is part of what you'll need to investigate. Remember, this project will account for 60% of your final evaluation. You have 1 stellar cycle to complete your research and present your findings." As the professor's form dimmed to signal dismissal, Crix carefully gathered the sealed crystal. His team huddled together in their respective environmental fields, each already processing the challenge in their own way. Zeph's surface swirled with calculations, Nari's limbs traced possible research patterns in the air, and Crix's own crystalline structure hummed with the beginning frequencies of a research algorithm. "We should start with basic planetary characteristics," Crix suggested, his facets organizing into research mode. "Something about this world created a species capable of surviving conditions that would destroy most of us. We need to understand what we're dealing with." "Agreed," Zeph flowed, their surface temporarily forming into a rough approximation of Earth's spherical shape. "Though I suspect we'll find more questions than answers at first." Nari adjusted her harness straps nervously. "One thing's certain, this project will be unlike anything we've studied before." None of them realized just how right she was, or how their research would challenge the very foundations of xenobiology. As they left the crystalline chamber, their sealed data crystal held the beginning of a discovery that would change the galaxy's understanding of life itself. The research pod hummed quietly as Crix aligned his crystalline structure with the data interface. His facets scattered light across the holographic displays, each beam carrying streams of information about Earth's basic planetary characteristics. Beside him, Zeph had formed themselves into a wide, shallow pool to better absorb the data patterns, while Nari floated in her modified harness, surrounded by floating screens. "This can't be correct," Nari whispered, her gossamer limbs trembling as she rechecked the gravity readings. "The surface gravity is 9.8 meters per second squared. That's nearly 10 times my homeworld's gravity." Zeph's Mercury surface rippled with concern. "The atmospheric pressure readings are equally disturbing. The humans live under constant pressure of 100 and 1.325 kilopascals at sea level. My fluid form would be compressed to half its normal volume in such conditions." Crix chimed thoughtfully, his crystalline matrices processing the raw data. "The oxygen levels are what concern me most. 21% oxygen in the atmosphere. That's highly corrosive to most known materials. Even our most advanced ships need special coatings to withstand short exposures to such conditions." The holographic display shifted, showing a three-dimensional model of Earth rotating slowly in the center of their research pod. The planet's blue oceans and white cloud patterns seemed deceptively peaceful. "Look at these temperature variations," Zeph observed, their surface forming rippling patterns of analysis. "Humans regularly survive in environments ranging from -40 to +40 degrees Celsius, sometimes in the same region during different seasons." Nari pulled up another data set with a graceful gesture of her delicate limbs. "The electromagnetic field readings are off the scale. Their planet's core generates a magnetic field so powerful it deflects stellar radiation. Most species would experience severe disruption to their neural patterns under such conditions." Crix refracted thoughtfully, his crystalline structure humming with calculation frequencies. "Yet none of these factors alone explains the Class 12 designation. The Vargans evolved on a high-gravity world. The Methane Collective thrives in pressurized environments. Even the electromagnetic fields aren't unprecedented. It's the combination," Zeph realized, their Mercury form swirling with excitement. "Each factor alone might merit a Class 6 or Class 7 rating. But together, their surface rippled as they processed the implications." Nari adjusted her harness to face her teammates directly. "And we haven't even started analyzing the geological activity yet. Look at these readings. Active plate tectonics, thousands of volcanoes, regular seismic events that can reshape entire landmasses." The holographic display updated to show a cross-section of Earth's crust, revealing the dynamic processes beneath the surface. Crix's facets pulsed with surprise as he processed the data. "The entire planet is alive in a geological sense," he chimed, his crystalline structure resonating with amazement. "The crust floats on a sea of molten rock, constantly moving, breaking, and reforming. Humans built their civilization on top of a planetary-scale fusion reactor." Speaking of fusion, Zeph flowed closer to the display. "Their star bombards the planet with enough radiation to destroy most species' genetic structures. Yet humans evolved complex repair mechanisms to deal with DNA damage." Nari's limbs traced patterns in the air as she correlated different data sets. "They don't just survive these conditions. They thrive in them. Human settlements exist in almost every environmental extreme their planet offers. From frozen tundra to scorching deserts, from high-altitude mountains to underwater habitats. We need to dig deeper," Crix decided, his facets organizing into research patterns. "These baseline readings explain the physical challenges, but something's missing. No species should be able to adapt to so many deadly factors at once." Zeph's surface formed a series of questioning ripples. Could their adaptation to these conditions explain their rapid technological advancement? They achieved space flight barely 2 centuries after discovering powered flight. "One thing's becoming clear," Nari said, her voice carrying a note of awe. "We're not just studying a death world. We're studying a planet that turns deadly conditions into evolutionary advantages." The research pod's displays flickered with new incoming data, promising more revelations to come. None of the students noticed that their preliminary findings had already triggered several high-priority alerts in the Academy's central database. The research pod's emergency shields activated automatically as the simulation of an Earth hurricane filled the chamber. Nari's support harness anchored itself more firmly as she watched the swirling vortex of wind and water vapor, her gossamer limbs quivering at the raw display of power. "The humans call this a Category 5 hurricane," Crix explained, his crystalline structure vibrating in harmony with the simulation's energy readings. "Wind speeds exceed 200 kilometers per hour, and the storm system can span hundreds of kilometers." Zeph's mercury form coalesced into a tight, defensive sphere. "And these occur regularly. The energy output is equivalent to several fusion reactors." The simulation showed coastal cities in the hurricane's path. Instead of mass evacuation or underground shelters, the images revealed humans calmly boarding up windows and stocking supplies, following well-established protocols with practiced efficiency. "They treat it like a minor inconvenience," Nari observed, her voice filled with disbelief. "Look at their warning systems. They track these storms from formation to dissipation, even giving them names as if they're keeping pets." The display shifted, showing a different weather phenomenon. A funnel of intense wind descended from dark clouds, tearing across a vast plain. "Tornado," Crix chimed, his facets refracting data streams. "A vertical vortex of wind that can appear with little warning. The strongest ones can drive straws through solid metal barriers." "Through metal?" Zeph's surface rippled with shock. "My liquid form would be dispersed into droplets instantly. Even gathering myself back together would be impossible in such conditions." The simulation cycled through more Earth weather patterns: blizzards that buried entire regions in frozen water, thunderstorms that split the sky with plasma discharges, flash floods that transformed dry ravines into raging rivers within minutes. Nari adjusted her viewing screens, correlating weather data with human development patterns. They built their earliest civilizations in river valleys prone to flooding. Instead of avoiding these dangerous regions, they developed irrigation systems and flood control methods. "The lightning is what fascinates me," Crix said, his crystalline structure pulsing with excitement. "Humans didn't just learn to protect themselves from atmospheric plasma discharges. They learned to harness their power. Their first electrical grids were inspired by lightning." Zeph flowed between different data displays, their mercury surface reflecting the simulated weather patterns. "Their agricultural practices actually depend on these extreme conditions. They use storm systems for irrigation, seasonal temperature changes for crop cycles, and even harness wind energy for power generation." The simulation paused on a global weather map, showing multiple extreme weather events occurring simultaneously across Earth's surface. "Here's something incredible," Nari announced, her limbs gracefully manipulating the data streams. "Humans can live comfortably in temperature ranges that would freeze or vaporize most species. They've built cities in regions that experience both extremes within the same solar cycle." "Not just cities," Crix added, his facets organizing the information into new patterns. "Look at their weather modification attempts. Cloud seeding, storm tracking, atmospheric monitoring networks. They're not content just surviving these conditions. They're trying to control them." Zeph's surface formed complex ripples of contemplation. "It's as if their planet's hostile weather forced them to develop advanced technology faster. Every natural threat became an opportunity for innovation." The research pod's displays filled with historical data, showing how human civilization adapted to and thrived under conditions that would cripple most spacefaring species. "We need to update our research focus," Nari suggested, her harness swaying gently as she organized their findings. "Earth's weather isn't just a series of deadly phenomena. It's an integral part of human development. They don't survive despite these conditions. They evolved because of them. Crick's chimed in agreement, his crystalline structure resonating with academic excitement. Their adaptation to extreme weather patterns might explain their rapid advancement in planetary engineering on other worlds. They're already terraforming their neighboring planet Mars and implementing weather control systems there that would take most species millennia to develop. Zeph added, their mercury form shimmering with realization. As the students documented their findings, a new alert appeared on their screens, incoming data about Earth's indigenous life forms. Their study of weather patterns had only scratched the surface of their Deathworld's mysteries. The holographic display in the research pod filled with images of Earth's wildlife, each specimen more incredible than the last. Zeph's mercury surface rippled with increasing agitation as they processed the data. Over 8 million known species. Their liquid form trembled. Most habitable planets support fewer than 10,000 complex life forms. The energy requirements alone should make this impossible. Nari's gossamer limbs danced across her control panel, sorting through categories of Earth's predators. The variety of hunting strategies is astonishing. Some use pure strength, others employ toxins, and many utilize complex social behaviors we've never seen before. Look at this specimen, Crix chimed, his crystalline structure projecting an image of a saltwater crocodile. A reptilian ambush predator that has remained virtually unchanged for millions of years. Its bite force would crack my hardest facets like cheap construction crystal. The display shifted to show a pride of lions coordinating a hunt. Nari instinctively raised her harness higher as she watched the precise teamwork of the predators. Humans evolved alongside these creatures, she noted, her voice filled with wonder. They weren't even the apex predators of their own world for most of their development. How did they survive? Zeph formed a series of analytical ripples across their surface. Through innovation. Look at these early human settlements. They developed weapons, tools, and hunting strategies that compensated for their physical limitations. The holographic display updated to show microscopic images, causing all three students to recoil in shock. By the 7 suns, Crix's crystalline structure vibrated with alarm. Their planet is saturated with microscopic life forms. Bacteria, viruses, fungi, billions in every cubic centimeter of soil. These microorganisms are engaged in constant chemical warfare, Zeph observed, their mercury form contracting defensively. They produce compounds that would dissolve my outer membrane in seconds. Nari adjusted her viewing angle, focusing on human medical data. Humans don't just survive these microscopic threats. Their bodies maintain complex defensive systems against them. They harbor entire ecosystems of beneficial microorganisms within their own bodies. The display cycled through more examples of Earth's biodiversity. Venomous snakes that could kill with a single bite, spiders that paralyzed prey with neurotoxins, plants that could cause severe chemical burns on contact. Here's something fascinating, Crix announced, his facets organizing new data streams. Humans have learned to use these deadly organisms to their advantage. They extract medicines from venoms, develop antibiotics from soil bacteria, and study extremophile organisms for biotechnology. Zeph flowed closer to the display showing human medical achievements. Their understanding of biochemistry advanced rapidly because they had to constantly defend against biological threats. Most species develop medical science to treat accidents or age-related conditions, but humans had to create treatments for countless natural toxins and pathogens. Even their companion animals are remarkable, Nari added, bringing up images of domesticated species. They formed symbiotic relationships with predators like wolves, turning them into protective allies. They keep venomous creatures as study subjects and dangerous organisms as pets. Crix's structure hummed thoughtfully as he processed the implications. Earth's biodiversity forced humans to become ultimate adapters. They couldn't specialize in defending against any single type of threat. They had to develop strategies for surviving everything their world threw at them. The research pod's analysis systems highlighted a new pattern in the data, drawing their attention to human genetic information. This is unprecedented, Zeph's surface swirled with excitement. Human DNA shows signs of viral incorporation throughout their evolutionary history. They didn't just fight off pathogens. They absorbed useful genetic material from them. A species shaped by constant biological warfare. Nari mused, her harness swaying gently. No wonder they advanced so quickly in genetic engineering and molecular biology. They've been studying warfare at the cellular level since before they discovered cells existed. As the students documented their findings about Earth's complex biosphere, their research computers began correlating this data with the historical records they'd discovered earlier. A new pattern was emerging, one that would challenge everything they thought they knew about species development. Historical holograms danced through the research pod as the team delved deeper into humanity's developmental timeline. Nari's gossamer limbs traced the progression of human civilization across her screens, each discovery more remarkable than the last. They mastered fire during their early development stage, she noted, her voice filled with disbelief. Not just using natural flames, but creating and controlling combustion at will. Most species would consider purposefully generating plasma a sign of madness. Crix's crystalline structure hummed as he processed the archaeological data. The control of fire changed their entire species. It allowed them to cook food, increasing caloric intake. It provided warmth, letting them expand into colder regions. It even influenced their social development through communal gathering points. Look at their early migrations. Zeph's Mercury surface rippled with excitement. They spread across their planet despite having no natural defenses against extreme cold or heat. Instead of evolving thick fur or specialized cooling systems, they created portable environmental protection. The display shifted to show ancient human settlements along riverbanks prone to flooding. Rather than avoiding these dangerous areas, the historical data showed increasingly sophisticated water management systems. Fascinating adaptation strategy, Crix chimed, his facets refracting the holographic data. They turned periodic flooding from a threat into an agricultural advantage. These early irrigation systems increased food production beyond anything their hunter-gatherer ancestors could achieve. Nari adjusted her harness to examine details of early human architecture. Their buildings evolved to withstand multiple environmental threats simultaneously. Look at these coastal structures, designed to resist both wind and water while maintaining internal temperature control. Speaking of temperature control, Zeph flowed between different historical periods. Their development of heating and cooling technology is remarkable. Instead of limiting themselves to climate-appropriate regions, they modified their environments to suit their needs. The timeline advanced, showing humanity's growing mastery over their world's natural forces. Lightning rods redirected atmospheric plasma. Seawalls held back ocean surge. Underground shelters protected against windstorms. Here's something incredible, Crix announced, his crystalline structure vibrating with academic excitement. They developed prediction systems for natural disasters. Not just simple observation, but complex mathematical models to forecast dangerous events before they occur. Zeph's surface formed analytical patterns. That level of predictive capability would require extensive understanding of atmospheric physics, geological processes, and statistical analysis. How did they develop such complex sciences so quickly? Because they had to, Nari responded, her limbs gracefully manipulating the data streams. Look at these mortality statistics. Every time a natural disaster struck, they didn't just rebuild. They improved their defensive systems and expanded their scientific understanding. The display showed humans venturing into increasingly hostile environments, scaling frozen mountains, exploring ocean depths, surviving in scorching deserts. They're using the planet's dangers as a testing ground, Crix observed, his facets pulsing with realization. Each environmental challenge becomes an opportunity to develop new technologies and survival strategies. More than that, Zeph added, their Mercury forms swirling thoughtfully. They're actively seeking out these challenges. Most species avoid danger. Humans treat it as a puzzle to be solved. Nari brought up comparison charts showing technological development rates across known spacefaring species. Their rate of advancement is unprecedented. Every natural threat they overcame accelerated their development in related fields. Atmospheric dangers led to aerospace technology. Geological hazards sparked materials science. Ocean exploration drove pressure-resistant engineering. It's as if the entire planet is a training ground. Crix chimed, his crystalline structure resonating with the implications. Each deadly aspect forced them to innovate, adapt, and overcome. Their Deathworld didn't just test them, it taught them. The research pod systems began correlating this historical data with their previous findings about Earth's weather patterns and biodiversity. As the students documented humanity's remarkable journey from survival to mastery, their computers detected an emerging pattern in human physiology that would lead them to their most stunning discovery yet. The research pod's medical scanners projected detailed holographic models of human physiology. Zeph's Mercury surface rippled with increasing agitation as they processed the data streaming through their specialized sensors. Their healing capabilities violate everything we know about biological repair systems, they announced, their liquid form swirling with excitement. Look at this bone healing process. They can recover from structural damage that would permanently disable most species. Nari's gossamer limbs trembled as she examined the cardiovascular data. Their endurance capacity is extraordinary. They maintain homeostasis through a cooling system that expels excess heat through millions of specialized skin organs. They can literally run in conditions that would cook most species alive. The implications are staggering. Crix chimed, his crystalline structure vibrating as he processed neural activity readings. Their pain tolerance and recovery mechanisms suggest they evolved under constant physical stress. Most species would develop avoidance responses to such conditions. The display shifted to show human performance data under various environmental pressures. Athletes running marathons in scorching heat, swimmers crossing freezing waters, climbers surviving in oxygen-depleted altitudes. They're persistence predators, Zeph observed, their surface-forming patterns of analysis. These endurance capabilities didn't develop for defense. They evolved to exhaust prey through relentless pursuit. No wonder they excel at long-term space missions. Nari manipulated the controls, bringing up cellular-level scans. Their immune system is like nothing we've ever studied. Multiple layers of defense, adaptive response mechanisms, and the ability to develop resistance to new threats. They're walking biological warfare laboratories. Even their sleep cycles are remarkable, Crix added, his facets refracting neural pattern data. They partition their consciousness, maintaining awareness of threats while portions of their brain undergo maintenance. Most species require complete shutdown for neural recovery. The medical scanners highlighted the human digestive system, causing all three students to pause in amazement. They can digest substances that would be lethal to most carbon-based life forms, Zeph noted, their mercury form rippling with disbelief. Their digestive chemistry adapts to new food sources within a single generation. It's as if they evolved to eat anything that might contain nutrients. The redundancy in their organ systems is fascinating, Nari observed, her harness swaying as she studied the anatomical models. Secondary kidneys, a liver that can regenerate, backup sensory processing in their brain. They're designed to survive catastrophic damage. Crix's crystalline structure hummed thoughtfully as he compiled the data. Their reproduction system includes programming for rapid adaptation. Environmental stresses can influence genetic expression within a single generation, allowing their offspring to better survive specific threats. The display showed examples of human physical achievements. Free divers holding their breath for impossible periods, ultramarathon runners covering vast distances, strength athletes lifting enormous weights. Look at their muscle tissue response. Zeph's surface swirled with excitement. Physical stress doesn't just damage them, it triggers enhanced growth. They literally become stronger when exposed to survivable levels of damage. Their nervous system adaptation is equally impressive, Nari added, her limbs gracefully tracking the data streams. They can learn complex physical tasks through repetition, gradually optimizing neural pathways until actions become automatic. Their brain actually restructures itself to improve performance. Crick's facets pulsed as he correlated their findings. Every aspect of their physiology shows signs of evolutionary pressure from their Deathworld. But instead of specializing to avoid specific threats, they developed general-purpose survival mechanisms that could handle anything. The research pod's computers began compiling their physiological findings with their previous research into Earth's environmental conditions. A new understanding was emerging, one that would challenge the very foundations of xenobiology. "We've been thinking about this backward," Zeph realized, their mercury form coalescing with sudden insight. Earth isn't just a death world that humans survived. It's a crucible that forged them into something unprecedented in known space. As the students documented their discoveries about human physical capabilities, their research systems detected an unexpected pattern in human psychological data. They were about to learn that humanity's mental adaptations were even more remarkable than their physical ones. The research pod's neural interface systems projected complex webs of human psychological responses across its displays. Nari's gossamer limbs moved in mesmerized patterns as she studied the intricate mental processes. Their stress response system isn't just for survival, she noted, her voice filled with wonder. They can consciously channel fear and anxiety into heightened performance. Most species experience mental shutdown under extreme pressure, but humans, they actually improve. Crick's crystalline structure resonated as he analyzed human problem-solving patterns. Look at how they approach obstacles. When faced with a deadly challenge, their first instinct isn't to retreat, it's to experiment. They treat lethal threats as puzzles to be solved. Their learning algorithms are extraordinary, Zeph observed, their mercury surface forming complex analytical ripples. They don't just pass down survival knowledge through generations. They actively seek new challenges to expand their understanding. It's as if danger triggers curiosity rather than caution. The display shifted to show historical examples of human innovation, each sparked by encountering potentially lethal situations. They turned atmospheric plasma discharge into electrical power systems, Nari remarked, adjusting her harness to better view the data. They studied venomous creatures to develop medicines. They even harnessed atomic forces after discovering their destructive potential. Zeph's surface swirled thoughtfully. Their response to catastrophic events is particularly fascinating. Instead of avoiding disaster zones, they send teams to study them. They use every tragedy as a learning opportunity. Here's something remarkable, Crick's chimed, his facets organizing new data streams. Their entertainment includes simulated danger. They deliberately expose themselves to controlled fears to experience excitement. They turn survival scenarios into recreational activities. The screens filled with examples. Humans climbing sheer cliffs without safety equipment, diving into ocean depths, racing vehicles at breakneck speeds. Their risk assessment capacity is unique, Nari noted, her limbs tracing the patterns of human decision-making. They can simultaneously recognize the deadliness of an activity and calculate acceptable safety margins. It's not recklessness, it's precise danger management. Zeph flowed between different data sets, their mercury form rippling with realization. Their collaborative response to threats defies evolutionary logic. Instead of competing for safe territories, they form larger groups and share resources when danger increases. The psychological impact of their death world created something unprecedented, Crick's added, his crystalline structure humming with academic excitement. Their neural pathways show adaptations for both individual survival and group cooperation. They can switch between self-preservation and collective action instantly. The display highlighted human emergency response protocols, showing communities uniting in the face of disasters. Most species develop rigid social hierarchies under threat, Nari observed. But humans demonstrate remarkable flexibility. They can form temporary leadership structures, adapt to changing conditions, and reorganize their entire society if needed. Their information sharing is equally impressive, Zeph noted, their surface-forming patterns of analysis. They don't just warn others of dangers. They systematically study, document, and distribute survival knowledge. Their educational systems are built on the foundation of overcoming deadly challenges. Crix's facets pulsed as he processed the psychological data. Their creative problem-solving abilities seem to be directly linked to their exposure to constant threats. Each generation builds upon previous solutions, leading to exponential technological growth. The research pod systems began correlating their psychological findings with their previous research, revealing a pattern that made all three students pause in amazement. "We've discovered something revolutionary," Nari whispered, her harness swaying gently. Earth's classification as a deathworld isn't just about its physical dangers. It's about how those dangers shaped human consciousness into something entirely new. The neural interfaces detected unprecedented patterns in human collective behavior, promising even more startling revelations. As the students prepared to compile their findings, they realized their research would challenge not just xenobiology, but the entire galactic understanding of species development. The grand auditorium of the Galactic Academy hummed with anticipation as representatives from 30 different species gathered for the xenobiology research presentations. Crix's crystalline structure sparkled under the ambient light as he took his position at the center platform, flanked by Zeph's shimmering mercury form and Nari in her precision-adjusted harness. "Distinguished faculty and honored guests," Crix began, his facets projecting data streams into the holographic display space. "Our team was assigned to study Earth's classification as a Class 12 deathworld. What we discovered challenges everything we thought we knew about planetary development and species evolution." The auditorium's atmospheric processors whirred as hundreds of beings shifted in their environment-controlled seats. Zeph's surface rippled as they activated the first series of research visualizations. Earth's surface gravity, atmospheric composition, and weather patterns alone should make complex life impossible, Zeph explained, their mercury form flowing through the presentation sequences. Yet these conditions created something unprecedented, a species that doesn't just survive lethal environments, but thrives because of them. Nari's gossamer limbs gracefully manipulated the neural interface, bringing up their biological research data. Human physiology shows adaptations that seemed contradictory until we understood their true significance. They possess both incredible durability and remarkable flexibility. Their healing capabilities, endurance, and adaptive immune responses aren't just survival mechanisms. They're evolutionary advantages forged by constant challenges. The display shifted to show Earth's geological and meteorological data, causing several audience members to activate their defensive shields reflexively. Most species avoid planets with active plate tectonics, atmospheric plasma discharges, and extreme temperature variations. Crix continued, his crystalline structure resonating with academic passion. Humans developed civilization in these conditions, turning each deadly feature into a stepping stone for advancement. Zeph's surface formed complex patterns as they presented their psychological findings. Their neural architecture reveals something extraordinary. Constant exposure to lethal conditions didn't create a cautious, defensive species. Instead, it produced beings driven by curiosity, innovation, and an almost inexplicable desire to explore dangerous situations. The auditorium's data systems struggled to process the wealth of information as Nari brought up their cultural analysis. Human advancement isn't despite their deathworld environment, it's because of it. Each catastrophe sparked new technologies. Each threat led to better understanding. They don't just adapt to overcome challenges. They actively seek them out. Professor Xylan's crystalline form shimmered with interest from the front row as Crix presented their revolutionary conclusion. Earth's classification as a Class 12 deathworld requires fundamental revision, he announced, his facets pulsing with conviction. It's not just a hostile planet that somehow produced a spacefaring species. It's an evolutionary crucible that forged humanity through constant challenges, extreme conditions, and endless opportunities for adaptation. The holographic display filled with their compiled research, showing the intricate connections between Earth's deadly features and human development. Their planetary conditions created beings capable of surviving anywhere, Zeph added, their mercury form swirling with enthusiasm. Humans don't need specialized environmental systems like most species. They adapt, improvise, and overcome using skills honed by generations of surviving the impossible. This has profound implications for our understanding of species development. Nari concluded, her harness swaying gently. Earth isn't a paradox of evolution. It's a blueprint for how extreme conditions can produce extremely capable species. The auditorium erupted with multi-species discussions as the presentation concluded. Professor Xylan's colors shifted to academic approval as she rose to address the gathering. This research changes our understanding of Deathworld classifications, she announced, her crystalline form radiating authority. We must revise our approach to studying hostile environments and the species they produce. Earth isn't just a Class 12 Deathworld. It's a masterclass in evolutionary development. As the academic community buzzed with the implications of their discoveries, the three students shared a moment of quiet triumph. They had uncovered more than just the truth about Earth's classification. They had revealed a new perspective on the relationship between planets and the species they forge.